Hello, everyone. I'm Evan Doran, and I'll be your moderator today. Today's webinar, AI-Powered CAM, lightning fast, fully secure, no cloud required, will be presented by Mark Bissell, Senior Technical Specialist at HCL. In this webinar, he will discuss how on-premise AI-driven CAM software can securely speed up programming, even for complex machines and parts. If you have questions for Mark, please use the Q&A box on the right side of your screen. As a reminder, today's webinar is being recorded and will be available for on-demand viewing shortly after today's session. With that, I'll turn it over to Mark. Take it away.
Thank you, Evan. Today, we're going to be discussing how AI-powered CAM can automate CNC programming while keeping your data fully secure. So let's jump in. Today's webinar will focus on a few keys of CNC programming. AI is transforming CNC programming by automating programming, reducing effort, and accelerating CNC program generation. Shops need faster workflows while maintaining control over sensitive manufacturing data. And advanced AI capabilities can be deployed on-premise, keeping data secure and local. So we have a poll question for you today to start things off, and we'd like to know, how important is it for your CNC programming solution to keep data fully on-premise, not in the cloud? So why don't you let us know how you feel about that, and we'll go ahead and issue that poll. Hopefully you're looking at that poll now. Okay. Hopefully you were able to participate, and thank you for participating in the poll. So now let me go ahead and move on. As you know, manufacturers today face increasing pressure from multiple directions. Customers expect faster turnarounds, which puts pressure on programming and production schedules. And rising costs make efficiency and first-time quality more important than ever. There's also a skilled labor shortage, as you probably well know, and experienced programmers and machinists are becoming harder to find and harder to keep. And protecting ITAR and other sensitive manufacturing data needs to remain secure and under tight control. So we have another poll question for you that's related to that. Let's go ahead and start that poll. And what is the biggest challenge that your shop is facing right now? And we have a couple of multiple choice questions there for your answers there for you. But I also want you to know that if we missed your biggest challenge, you can also type it into the chat. Okay. So hopefully you're able to see and able to participate in that poll, and we want to thank you for your participation. So moving along, we might want to discuss why AI is important in manufacturing and how it's transforming CNC programming. Machinable features can be recognized automatically to accelerate programming and reduce lead time. And your best practices can be captured and reused to standardize and reduce material and tooling costs and improve quality. An expert system can learn as you program, which means you can do more with fewer programmers and help new hires become more productive faster. And you can create fully associative toolpaths that update automatically to design changes and help ensure that you're machining the latest revision of the part. And increase productivity and quality without sacrificing security. Now that we have a better understanding of why AI is important, let's briefly discuss the embedded automation and smart manufacturing included in every seat of CAMWORKS. To begin, CAMWORKS is an add-in to SOLIDWORKS that transforms your SOLIDWORKS into a fully integrated CAD/CAM system and allows the CAD and CAM model to become one and the same. All the CAD and CAM data is stored in a single file, and the CAM toolpaths are fully associative to the design model, so if a change is made to the design, the toolpaths will update automatically. CAMWORKS also includes feature-based programming. Unlike traditional process or operations-based CAM systems, feature-based CAM typically reduces programming time by 70% or more because multiple operations are created automatically for each part feature. And CAMWORKS also includes automatic feature recognition, and it's able to recognize over 20 different types of machinable features. Milling features, along with ID and OD turning features, are automatically recognized, as well as mill turn and Swiss turn features. And intelligence-based machining allows users to capture their best practices and reuse them later automatically. So next, let's take a look at this technology in action. So here's a transmission cover that is in SOLIDWORKS, and you can see there's machining on both sides of this part that would be required. So a couple of setups. I'm going to go to the CAMWORKS feature tree here and then extract the machinable features on the part. So this will find all the machinable features automatically and put them into the feature tree. I'm going to go ahead and generate operations here. And that generates all the operations. And then we can generate the toolpaths for machining. So very quickly, we're able to find all the machinable features, generate the operations for those features, and then create toolpaths to machine the part. And now I can run the simulation here, and you can see the part being machined virtually. So you can see both sides of the part have been machined. So 2 setups here. I'll compare the design model to the machined model, and you can see everything is in green, which is good. And you can also see, if I zoom up here a little bit, let me turn this off. I'll go zoom up and you can see where it's also been deburred. So the sharp edges have been chamfered here to deburr the part right on the machine. So all that was done for me automatically. Looks really good. Also, there's another configuration here. So you'll see here where there's another configuration where the part has been lightened. So it has lots of pockets have been milled or cut into the part or need to be cut into the part. And you can see here where CAMWORKS also supports these multiple configurations. So I'll go to a second configuration, which is the lighter version. So I have the default version is still there. And now I have this new lighter version, and I'll go through the same process, just extracting the machinable features. And this now will find all the pockets on the part as well in this new configuration. And it will now extract all the machinable features, and it also finds those features with the fillets as well. So, and now you can see all the features here in the feature tree have been added, and for the lighter version. And what I'll do now is, let's see, we can go and generate the operations. This is the next step. So create all the operations for machining, and then go ahead and generate the toolpaths. And you can see where down here where multiple toolpaths are being generated simultaneously using the various cores on the computer. So it is multitasking, you might say, using multiple cores on the computer to generate toolpaths simultaneously. So different operations and toolpaths are being generated simultaneously. Okay, and we can simulate now. And you can see the pockets being machined here with the fillets in the bottom as well. All right. And I can compare the machined model to the design model again, and you can see it's been machined on both sides of the part. And everything looks good here. There's a little bit of red there on some of those holes that were they were designed as the tap drill. I'm going to go ahead and create the G-code here. And this will generate the G-code for the machine. So you can see how quickly I'm able to program using this technology. And, this is all on premise. It's not, there's no cloud required. I'm able to program parts nearly as fast, or probably as fast as what you could even upload a part to the cloud. So this is very fast for programming. And you can see the G-code here for the machining. This is the NC editor from CAMWORKS, powered by Simco. Okay. So I hope you were able to see how we can greatly reduce programming time, how, automated the process really is. As a result of that, new programmers can work with more confidence because they're benefiting from the technology that's already been stored by more advanced programmers and more experienced programmers, and it allows for more consistent results that are achieved across the various programmers. So you get away from the every programmer having his own idea about what tools and so on to use, and instead things become much more consistent. It's best to take the best processes, best practices, and use those automatically. And that's what the system is doing here. In fact, we're going to talk more about that here shortly. So let me move on. So what does AI-powered CAM look like when it's in practice? You can store machining strategies while you're working. So as you're programming, and every successful program strengthens the automation. And you can build a feature library with proven machining strategies to create an expert system. And these features that we're talking about, whether it be pockets or holes or bosses or slots, any type of feature, once programmed, it's not part dependent. So you could have those same features on other types of parts, and CAMWORKS will be able to automatically program those features. And it'll recommend the tools and operations and machining methods based on proven past results. And decisions become automated to reduce manual choices and apply established best practices. And the system continuously improves and becomes more efficient as additional data is collected. So next, let's look at another example of how an expert system like CAMWORKS can automatically select the tools and operations for different size features and how machining best practices can be saved back to the technology database. So here's a part with various size pockets and various depths of pockets as well. And so if I go and look at this and go over to the CAMWORKS feature tree, you can see I have a Haas machine selected. I have my stock defined. It's done for me. And you can see here some defaults, a millimeter on each side, a millimeter on the top of the part, and 3.5 millimeters underneath for holding on to. There's also a coordinate system here that's at the center of the stock. So I'll go ahead and extract the machinable features here. And now you can see all those and generate the operations like we did before. I think you know the routine here. I might combine the operations. This will help reduce the number of tool changes and also cut down on the size of the operations tree. You can see that there. And then I'll generate the tool paths for machining. And then go ahead and simulate again. And so here you can see where CAMWORKS has automatically selected different size tools for each of the different size pockets and different depths of pockets. It'll also do that for the tools, or I'm sorry, for the holes and tapped holes. It'll automatically select the correct tools as well. Okay. So very efficient. You can see here where there's a 2 millimeter tool right here. Let's suppose I want to make a change here. So I'm going to edit this operation, and I'm going to change the tool, and I'm going to rough these smaller pockets with a 3 millimeter tool. And let's select that and then preview that. So this will machine, rough machine with the 3 millimeter tool instead of the 2 millimeter. Okay. You can see that 3 millimeter tool here. Then it'll finish with the 2 millimeter and a 6 millimeter and a 3 millimeter for the medium pockets, 10 millimeter and a 6 millimeter for the larger pockets. So automatically selecting the tools for me. You can also see where it did the same for the various holes that are in the part as well. So very efficient. And the technology really helps programming parts like these. Let's also suppose I might want to make another change. Let me edit this rough milling operation. Let's just suppose that at the machine, I had a problem where chips were packing up. So I'll go here, and on these deep pockets, I'll make 2 passes in depth instead of just a single pass. And if I zoom up here, you can see there are now 2 passes in depth there. So this will help with that chip packing out of the machine. Might have been something I didn't realize until I got out to the machine. And so I've made that change. And you can see here, that's irregular pocket 17. I'm going to go to that feature in the feature tree. And I'm going to save that operation now back to the technology database. So, and I'll do the same thing for the 3 millimeter tool that we used on pocket 1. Let's save that strategy back to the technology database so that all future programs will now use the 3 millimeter tool for roughing on the small pockets, and it'll make 2 passes on the larger pockets. Okay. Let's also suppose there might be a design change. So I'm going to go here and let's change this dimension. And you'll see where, let's make this 45 millimeters, and you'll see where the outer pockets, larger pockets, will get much larger, and you can see that there. And then if I go back to CAMWORKS, it'll automatically recognize that change and automatically rebuild the toolpaths for me. So the toolpaths are fully associative to the design model, and you can see how quickly it can accommodate those changes, design changes, so revisions. So, and here it goes ahead and machine again. And if I compare the design model again to the machined model, You can see everything looked good there and looks great. So it's all been updated. And so I hope you can see how one improvement will benefit all the future programs. And programming consistency is maintained every time it sees pockets of these sizes or depths or material, or it can be different materials. It will, CAMWORKS will select the correct tools and so on. And if it doesn't, that's fine. You can go and make a few changes and then save them back to the database, just like I did here. So hopefully you can see how this technology can benefit you. If I move on, one of CAMWORKS' strengths is also its ability to support a wide range of CNC machines. So lasers, water jets, and routers are all supported. 3 to 5 axis vertical and horizontal mills of all types really are supported as well. Both 2 and 4 axis CNC turning centers, or lathes, are supported, as well as complex mill turn and multitasking machines. And Swiss-style CNC machines are also supported, as well as 2 and 4 axis wire EDMs even. So a really wide range of machines that are supported using CAMWORKS. And now let's take a look at how CAMWORKS can be used in SOLIDWORKS assembly mode to program a cavity in a mold. So here's a packaging mold, a vacuum packaging mold. You might recognize that this would be for razors and some packs of razors that would be inside this clear plastic packaging. So this might be a mold that we want to machine. You can see here that I have a Haas selected, the Haas VF3 selected again. The stock is just a bounding box here. And the coordinate system is at the center of the stock. And here I can go ahead and create a setup, and then go ahead and create a multi-surface feature for machining the mold. And I have a strategy already assigned or already created for these types of molds, and I'm going to select that strategy and then say all displayed. So this will say I want to machine the entire mold, and then go ahead and generate the operations for machining. And you can see the operations here. So the first one is a 12 millimeter roughing operation, and I want to create an avoid feature. I don't want it to rough the top of the part. I said all displayed, but that includes the top of the part. So I want to tell it here that I don't want these operations to machine that flat top. We're supposing that this is already a machined blank, ready to put the cavity into or machine the cavity into. So here I'm turning on each of the avoid areas, turning on that avoid feature that I created so that those operations won't try to cut the top of the part. And now that I've done that, I can go ahead and generate the toolpaths. And you can see, several roughing operations here. It's also doing rest milling. And down here, again, you can see where I am, it is currently calculating multiple toolpaths. And right here, you can see that WIP, the work in process, which is the rest machining. So the subsequent roughing operations are roughing only the areas that need to be removed, only the remaining stock after the initial, in this case, 2 roughing passes. So I have a 12 millimeter roughing tool, a 6 millimeter, then a 3 millimeter roughing tool. So you can see all the different tool paths being generated here. It's just about done. There we go. And you can see here the 12 millimeter roughing, the 6 millimeter roughing, a 3mm roughing tool, then a 6mm to machine the flat areas on the mold, a 4mm ball nose is used to machine, and then 3mm for pencil milling. I'll go ahead and simulate this. I'm going to turn on turbo here so it'll be a little faster. And that's what the turbo mode's for here. Let's also set this so that it is for the next tool. This will show us after each tool. So that's what it looks like after the 12mm roughing. This is what it looks like after the 6mm, and then the 3mm, and then the flat area. I'll just keep clicking here. Now you can see it's doing the 4mm finishing across the mold. It's also doing some cross machining here as well. So I used a pattern project, but it also automatically calculates cross machining where it needs to be added in order to give me a better, smoother finish. And then it did the pencil milling here. So it's working on that, and now it's done. And now I can go ahead and create the, there we go, compare the design model to the machined model, and you can see everything in green is good. If it had any remaining stock, it would be in blue, and if I had gouged it, it would be in red. So I'm going to say okay here. All right, and so you could create these the strategies, and I'm going to go ahead and post here and generate some code. But I want you to know you could create these strategies for machining different types of molds, and you might add tools and put in some more finishing tools, and leave out some more some tools. Maybe you want more roughing tools or more finishing tools to create a better finish or better mold. You can decide your best practices and store them. So you can see the G code here. Okay. So I hope you're getting an idea of how you can automate the programming process, how you can store these strategies back to the technology database for reuse later. You can create as many of these strategies as you like and name them, give them different names, give them different, strategies, different names that you can recognize, and you can create a library of these strategies for machining the types of parts that you're machining on a regular basis. Okay. Okay, so next, let's just discuss a little bit about the Swiss machining. CAMWORKS Swiss machining supports advanced Swiss types of machines, and it's designed to improve programming efficiency and accuracy and confidence. So full machine simulation is available right inside SOLIDWORKS to verify the machine motion and detect collisions. Integrated machine-aware programming. This allows users to be able to see the machine while they're programming. So the programmer can consider the machine constraints and also reduce setup time and rework. And a powerful segmentation manager is included to easily divide long parts into manageable machining segments. And the sync manager has been enhanced to improve synchronization and improve control of simultaneous operations. And advanced operations and toolpaths have also been added to help streamline Swiss machine programming. So let's start with a mill turn part here. And the routine. So I created the features already. I've extracted the machinable features. Here I'm going to generate the operations. And you can see the different operations here. Maybe pick one of these like the turn roughing so that we can see what it looks like. The feature recognition works really well on mill turn and Swiss turn parts as well, because most of the features are 2.5 axis type features. So, and even you saw where the 3D molds can be easily machined. Down here, you can see the sub-program or sub-spindle is also being used. And I'm going to add here a main spindle op or operation. And I'm going to drag and drop that here down here. Let's see, after that milling op, so that I can create a sub-spindle operation to transfer the part. So I'm going to select standard transfer there, and that will transfer the part from the main spindle to the sub-spindle. Okay. And then I'll go ahead and simulate again. So you can see the part being roughed out, the ID being done there. Here you can see the C-axis is being used to machine those grooves. And I might mention CAMWORKS also supports B-axis machines as well. So, and continuous simultaneous B-axis machining as well. So here you can see it now going over to the sub-spindle, doing the work over on the sub-spindle, doing the boring there, finish boring, and then doing the drilling and tapping there on the backside of the part. Compare the part again. You can see here where if I gouged it, it would be in red. Green is good. And if there was any stock remaining, it would be in blue. Looks good. Let me zoom up a little bit here and split the part. Well, yeah, let me split the part in half here. Yeah, there we go. And we can see that the inside has been machined also accurately. All looks good there. We'll go ahead and post-process, generate some code again. And this time just hit fast forward and it generates the program for me very quickly. And you can see here the program ready to go to the CNC machine. Okay. Okay. Let me now switch over here. Excuse me, a little dry here in Phoenix. It's a dry heat, as we like to kid, like to joke. We go to the CAMWORKS feature tree. You can see here I've already extracted the machinable features, and look at just a handful of features are really required for this part. So it doesn't take long. And then here you can see I've generated the operations for machining as well. You know the routine, but I wanted to show you here the sync manager where I can control the synchronization of the different operations on the main and sub spindle. And if I turn on machine aware here and turn on all tools, you'll be able to see the machine here in SolidWorks and CAMWORKS to be able to check your setup. I'll go to simulate here and we can go ahead and run the simulation. And you can also see where I had segmented this part so it would do the part in 2 segments so that it would not come out of the back of the guide bushing. And you can also see the milling here as well. And switches over to the sub-spindle and does the machining on the sub-spindle as well. Okay. Looks really good. I'll compare the machined model to the design model again. You can see some red there where the part is modeled with the major diameter. And so now it's been machined. And so it shows the minor as well. Inside the part, it looks good. Turn that off, say okay. And we can turn off the machine aware. Let's zoom back in here. And now you can see the part here. Okay, and then we can go ahead and post-process. So let's generate some code here for this one. Fast forward again, and then say okay. And this time you'll see where the editor opens up with 2 channels, one for the main and one for the sub. And the timing codes are synced here. So I can see exactly what's going to happen on each of the spindles and make any final changes that might need to be made, comments or so on. And everything looks good. So I hope you can be able to see how for mill turn and Swiss turn parts, we can, the CAMWORKS can also maximize the value of your CNC equipment and advanced CNC equipment. And it also reduces the programming complexity, and it enables done-in-one machining for a finished part. So, all right. True G-code machine simulation is also available for Swiss machines. And this is important because of the complexity of the machines and all that. This is simulating directly off the G-code. It replicates the machine kinematics, the tooling, and controller behavior. So it'll give us a very accurate virtual simulation of what's going to happen on the machine and directly from the G-code. So that improves the confidence of CNC programs in CNC programs and reduces the risk of collisions and so on. It also reduces setup time, and you can reduce scrap as well. So catch problems early and minimize the downtime and wasted material. Okay. Before we wrap things up, I'd like to just briefly review the results you can achieve by using this technology. CAMWORKS is not only powerful, but easy to use, and it can help you accelerate programming and reduce lead time. You can reduce cost of both material and tooling using the automation to standardize your CNC programs. And use the patented technology database, or TechDB, to automate the CNC programming process and at the same time improve the quality of your parts. And programs will update automatically, so you can meet engineering changes head on and have those programs update automatically to design changes. And reduce setup time and avoid costly collisions and take a quality product to market faster. A final comment I might make, and that is that the CAMWORKS TechDB is a perfect AI platform for future development. And you can expect more automation from HCL CAMWORKS in the future. The well-known author and entrepreneur Vider Keim once said, "Procrastination is opportunity's assassin." And implementing the latest integrated CAD/CAM technology will digitally transform your company. And automation's an ideal way to stay ahead of the competition. So I would encourage those listening to start today by taking the first step and setting up a personalized demonstration tailored to your specific requirements. To do so, visit camworks.com or the camworks.com demo URL shown on your screen. And I also want to make sure and mention that there are some flyers that are available to you in your Big Marker user interface.